Okay, here we've got a question, and what leaps out at you is this table, and seeing chi-squared in part A1, you know you're going to be doing a contingency table and a chi-squared distribution. You should still read all the words carefully though. And in the keywords in A1 here, form the data into a contingency table is a strong warning. This other thing in bold, anything in bold is always worth looking at. This is not yet the contingency table you need, because these things here are just percentages. We need to use the actual totals at each school in conjunction with the percentages to get the observed frequency. That's why we have to form it into a contingency table, and that's what you'll miss if you're careless on this question. So always read the words and use anything in bold and the exact words in the question to avoid error. That's why we've got a separate part A1, and only in A2 do we go on and actually do the chi-squared test. Now on a chi-squared test, don't forget to state your hypotheses. They're very easy. They always have the same form for a chi-squared test. Do a very clear table where you calculate your expected frequencies. Always be on the lookout for the two things that may arise. Does it become a 2 by 2 table? Do you have to combine rows or columns because you have expected frequencies of less than 5? Always be on the lookout for those. Having got two things, can you clearly state chi-squared calculated value and chi-squared critical value? To get this one, you'll need to state what the degrees of freedom are, a clear statement of how many degrees of freedom, what the critical value is, what the calculated value is. Draw a nice diagram to show the critical region, but also explicitly compare these two numbers, say which one is bigger, and reach a verdict on H0. Do you accept it or do you reject it? And then at the end you must interpret in context. So you can go back to the claim, but on chi-squared you're always looking for whether there is or is not an association between the two factors. So you can come out with a standard potted interpretation of either rejecting or accepting H0 in terms of an association, in this case between age and the school. In part B, we've got to interpret the result from A.E1 as it relates to the 22 to 34 age group. So in your calculations, you can look at the observed and expected pattern in this group and see the contribution towards the calculated chi-squared value. High contributions means there's a big mismatch between the observed and expected. Low ones means they're very similar. But you need to be talking about, within that group, whether more than expected or fewer than expected actually did attend the school in that area.